Good morning, Ajay. Am I audible?
Yes, sir. Clear and good, sir.
Let me also say good morning. Ajay,
Good morning, sir. Yes, sir. Yeah.
Okay, thank you.
Morning, Suresh. Once again, let me know, man.
Good morning, one and all present here. I welcome you all for the AICT Atal-sponsored online faculty development program on augmented reality and virtual reality, organized by Department of Electrical, Electronics and Communication Engineering, Geetham deemed to be University, Bengaluru campus. It gives me an immense pleasure to welcome our respected director, Geetham School of Technology, Professor Dinesh Seth, Distinguished Professor and Head of the Department, Electrical, Electronics and Communication Engineering, Dr. Rukmangathan TN, and today's speaker, Sri Suresh Pedincheri, and all participants of this FTP program. Now I invite Professor Dinesh Seth, Director, Geetham School of Technology, to speak a few words.
Good morning and a warm welcome to organizers, distinguished speakers, and participants. The outbreak of COVID pandemic in India has caused extreme distress to the students, faculty members, and is really a setback for the academic activities. And in this moment of crisis, AICT has endeavored to leverage digital access for the continuation of the academic upliftment of faculty through online mechanisms. AICT has progressively taken up various activities like webinars, faculty development programs, leadership talks, and these activities have been active, ensuring participation from different stakeholders with a positive outcome. Moreover, with the growing technology, the knowledge of the subjects has also expanded tremendously, and hence there is an urgent need to have faculties continuous development program on new topics, new technologies, and new pedagogies. And one such initiative is taken by AICTE through Atal scheme. And this agency is key to address the issues in the key emerging areas. And in these circumstances, a 5 days online FDP program through live sessions are being organized across India. Geetam Bengaluru campus was fortunate enough to get 4 FDP programs, and this is second such program in the series. And finally, FDP programs through Atal Academy is an appreciable initiative by AICT, training and developing a large number of faculty members to match the industrial and technological needs is really the need of the hour. I wish all the best to the participants for their learning journey. Thank you very much.
Thank you, sir. Now I invite Dr. Rukmankadan TN to speak a few words.
So good morning to one and all. I am very, very happy to see this initiative, and especially in the area of augmented reality and virtual reality. Why I am going to explain very soon. Reality for us means living in the three-dimensional world. And if I am in some particular place, Bangalore, and in office or any other place, I can feel, touch, breathe the air, get the smell. All five senses work excellently well in reality. So that is the ultimate goal, I suppose, for virtual reality, where the word virtual means that you almost get the same experience as what you are in the three-dimensional world. Okay. And then all of us have somehow or other, I think, have experienced virtual reality. And, all of us have dreams. And dreams, if you see, is really a virtual reality, I should say, because you see, feel, and all emotions come together. And that's really very impressive. And as you all know, brain is the biggest computer with much more capability than the single computer available on earth. So that is happening because of the images that are stored, or I don't know, I'm not a brain expert, but if you see, a lot of things happen, and the dream is the ultimate goal that should be there for uh, the scientists and engineers working in virtual reality. And just like tuning tests for artificial intelligence and all, I would say that pinch test must be the thing. See, when somebody has a dream and then wakes up, they pinch and see whether it is real dreaming and things like that. So the pinch test could be the best test one should aim for, being the scientists, engineers who are going to work in this area. So coming to the virtual reality, it started, I think, way early, but I've seen in conferences in SID also. See, you get the real immersive feeling. That means you don't see anything else, and that is the need of the hour. See, all of us are teaching now, and we have difficulty, frankly speaking, engaging the students in the virtual classroom. That is because I get a feeling that I'm talking to a screen and I'm not able to interact fully with the students. And students, I'm sure they are feeling that there is no meaningful this thing, because the information is in 2D and they cannot get all the feelings they get in the reality. The classrooms are much better, and I wish it comes we have classes as soon as possible. But till then, I think of course, if you look at even this virtual Zoom meeting and other things, it's a blessing in disguise, and it's great now that we are able to reach out to our students to whatever extent possible. And without such tools, we wouldn't have reached our students, and that would have been complete lockdown. I'm glad we have that, but there are other tools, and of course the experts are going to talk to you about that. And my wish is that day should come when the students can feel, or if there is an experiment being done, they should be able to participate in that, touch, feel. All these senses should be achieved by the students, and then the real engagement couldn't take place. And of course, the augmented reality, all of you know, in 2006, I think the Google map, the Earth, and put it. And I was very excited. I was scanning through that, and I visited the place I lived at different places like Holland and Japan, wherever we went. And see, there you have the map, and there is the overlay, and night driving, suppose you are doing. And then again, you have the windscreen, and then over that, one can overlay some graphics to improve your visibility as well as to guide you for the journey you have taken. And of course, there are many more potential applications. And I wish that the virtual reality and augmented reality will help the educational sector, especially because I think it is going to be great use for many youngsters to learn the subject very well. And I wish you a very happy session. And I'm sure the panelists will do great justice to the subject, and you will all emerge with better knowledge to apply in whatever fields you are interested, including research in the area. Thank you very much.
Thank you, sir. Our today's first session speaker is Sri Suresh Perincheri, Partner Technical Manager, PTC India. He has completed his BTech in Mechanical Engineering and MBA in Operations Research. He has a total work experience of 26 years. He has an experience of 16 years in driving partner business, partner coaching, and technical advisor. He has experience in CAD, CAM, CAE, PLM, IoT, and AR evangelist and consultant in automotive, defense, industrial, heavy engineering, and educational organizations. He also has experience in training and development for sales ecosystem South PhD Ring. He also worked as a project manager in engineering services for 1 year. He also has an experience of 3 years as R&D engineer in tractor industry designing higher HP hydrostatic steering agricultural tractors, and also 6 years as aeronautical engineering mechanical division in Indian Air Force. I welcome you, sir, for this FDP.
Thank you.
Now you can start the session, sir. Thank you.
Okay, I will share my screen. Just let me know, Saranga, if my PPT you can see.
Yes, sir, it's visible, sir.
Yeah. So first of all, I would like to thank Geetham University and the EECE department for giving me this opportunity. As rightly said by Dr. Dinesh and HOD EECE, that these technologies, AR, VR, is the present and the future. And it is helping companies in this COVID-19 situation, which is not going to go as soon as possible. So I'm happy to share my knowledge and experience. In PTC, we are an evangelist of these technologies, and we have been helping in multiple industries. And they have even given references and metrics and certification that yes, truly in this new normal, these technologies, those who have adopted early, have really benefited. So it's my uh, privilege to share in 6 sessions between today and tomorrow to all the faculties who are attending. So today's session, which is till 11:30, is on Industry 4.0 and digital transformation. So before we talk about AR and VR, these are all subset of these two main umbrella. We need to know why we are going for AR and VR and Internet of Things and other technologies like artificial intelligence, machine learning, and all those things. That is all part of business and companies and human beings driving towards digital transformation. And digital transformation is happening in multiple verticals and multiple industries. So once it is applied to our manufacturing segment, which is the main segment, which also increases all the parameters like GDP, etc., where we are trying for digital transformation, and that is called Industry 4.0. So I feel these two terminologies we should understand well. The why of all these AR, VR, once we understand, then we can appreciate the benefits of these technologies. So Industry 4.0, as many of you may know, is Madam Saranga, let me know if you are not able to see the PPT or something like that.
Yes, sir, it's visible, sir. You can continue,
Or
sir.
my audio is not coming. Yeah.
Yes, yes, sir.
So Industry 4.0 is a term coined in Germany where they wanted to automate all their manufacturing process and they wanted to go with the lean manufacturing process. And that's where this idea came up, and there are a lot of articles, the best being from Acatech, which talks about Industry 4.0. So to understand in brief, Industry 4.0 is Internet of Things and digital transformation process applied to the manufacturing area is what is Industry 4.0. So Internet of Things is definitely a technology which facilitates Industry 4.0, and it is really making a lot of inroads into our manufacturing industry. Now, along with IoT, we are having this term called digital thread. Now, when we do a product development or a process, it flows through different phases, starting from design, sourcing, testing, production, to distribution, and to the point of sale and use. Throughout these different life stages of the product, there should be a data which should be seamlessly flowing, connecting each other with a proper traceability and closed loop cycle. So that is what is called as digital thread. Then another term which we should all remember and understand is digital twin. Now the purpose of all these digital technologies is to virtually represent the physical product and process counterparts exactly the way it would behave in the physical context into the virtual. So that term is called digital twin. So in the entire process of digital transformation, digital thread and digital twin are the two major aspects of digital transformation and Industry 4.0. So since industry is adopting this fast, institutions like yours have to concentrate to produce engineers of tomorrow. The engineers of tomorrow, even at any core branches or combination branches, it is not enough if they have skills of that particular branch. They need to have multidisciplinary skills and they need to understand it well and to embrace this rapid change of the digital transformation. So that is where all these technologies to be understood by all the core departments and the new departments or disciplines which has come now in the institutions. So Industry 4.0 is actually the integration of cyber physical systems. We also say that it is a integration of the shop floor to the top floor, or to the operation technology to the internet information technology, IT. So there are a lot of systems which come in this process. And to cut short, the overall thing is that if you see this symbol here, this is PTC's logo. So on top, you can actually trace a P, which stands for the physical world. And at the bottom, you can trace a D, which stands for the digital world. It is also symbolizing the yin yang symbol with the Chinese talk about the male and female union. So it is a convergence of the physical world with the digital world is where the Industry 4.0 and digital transformation is helping us. We are able to exactly position whatever we create, the experiences we create in the digital world, to the people who are dealing with products and processes in the physical world, and vice versa. From the physical world, whatever is happening, we are able to understand in real time into our digital environment so that we can do a lot of permutation combinations to make better decisions. So PTC as a company also is helping industries to leverage the convergence of the physical and digital world. And with that vision, we changed our logo to this in 2010. Now, there are a lot of emerging technologies which everyone need to understand. If you are embracing any one or more of this, then yes, you are in the path of digital transformation industry 4.0. Now, for example, 3D printing, additive manufacturing. Earlier, 3D printing was done only for small components and only for looking at the form. But now, they are completely functional components can be made out in plastic as well as in metal with 3D printing. There is no metal being removed, only metal being added or plastic and other materials being added. And what you see in the digital world, in the CAD world, whatever you design, is directly printed out in a 3D printer. It's as fast and as simple as that. Similarly, we have other areas like advanced analytics. We are talking about advanced materials which are also bio-friendly, which can be easily disposed of, but still it are light and they can withstand all the great loads and other reactions and pressures which comes onto those materials. And thanks to these advanced materials, our physical products are becoming smaller and smaller with more power. Then comes the advanced robotics and cognitive automation, artificial intelligence, which also includes machine learning, biotechnology and biomanufacturing, blockchain, cyber security, which is very important in this cyber physical world. Then the, the usual way of design, simulation, and integration of the products is totally being replaced by the digital form. The physical form is limited to one or two. The prototyping of physical products is very much limited. It's all done in the digital form. Then people are concerned about energy conservation and storage. And for all this, we require very high performance computing or the next generation computing. Companies like Dell, HP are all working towards this. Then this is the topic which we are talking about, the interface of things, or the augmented reality, virtual reality, and mixed reality with different kinds of wearables, be it eye or handheld or computer, etc., with lot of technologies like gesture recognition, etc. So this is what is the topic for next 2 days. This is also an emerging technology, and then it is very strongly integrated with Internet of Things, where you talk about networks which will connect all the different things with multiple sensors built in each different things. So these are the different emerging technologies which we should understand. So what is the advantage of these emerging technologies? In a company, if you see, there are different departments which work, starting with engineering. Now engineering, which is focusing on accelerating the time to market, optimizing design, they need real-time simulation and virtual collaboration with a very close loop from design to production. So the digital transformation and industry 4.0 and all these technologies like Internet of Things, AR, VR is helping towards that for the engineering department. Coming to the sales and marketing department, they are able to capture the voice of the customer when the product is being used, and quickly they are able to convert that voice into a better product. And that is thanks to all these technologies, it's happening real time. And they're also able to give inspiring product demonstrations through augmented reality and virtual reality and mixed reality 3D experiences, where they are not required to have a physical product always. It can be shown through a handheld device or through an eyewear in the real experience. So most of the companies which are into big products, they are leveraging this technology to take this technology to even big trade fairs, where in the booth only one or two samples of their physical product will be there. Rest all variants, they are using these technologies to showcase to the interested customers. Next, the main thing where Industry 4.0 applies is the manufacturing and supply chain. There, these technologies are helping them to optimize their plant, monitor their assets and maintain their assets well, to increase the workers' productivity who are working on the machines, which ultimately ensures quality, compliance, and even worker safety. And this is all leading to reducing the operating cost and increasing the manufacturing and supply chain efficiency. Then after manufacturing, the next department is the customer operations. Here they are trying to focus on many value added services through collecting data from the product which is being given to the customer, so that they are able to use artificial intelligence to make better decisions, and also helping the customer themselves to self service the product. Gone are the days when we have all those printed catalogs and manuals which we don't even read, or even if you start reading, it's very difficult to understand. Now it's all AR, VR, and mixed reality enabled self-service instructions given to the customer themselves. And this is also helping because you are monitoring all these products which are connected with sensors. We are also able to understand and automatically replenish whichever is required. ATM is a great example. Most of the advanced ATMs are all connected. They understand when exactly the cash has to be replenished, and exactly at that time the people are sent and the cash is replenished. Same thing goes with supermarkets and other industries, etc. Then comes the customer service. Nowadays, most of the products are having almost all the features. But what differentiate one product with another is the service given to the customer by the company. For example, the aircraft engines, maybe GE or Rolls-Royce. It is not that they are selling that engines to the Boeings or Airbuses. What they sell is the service. They say, you pay us for 1 lakh hours of maintenance free service. And if that is the commitment, it is only possible if they are able to have a continuous monitoring of the performance of the engine. So because of these technologies, the services have become innovative. The uptime of the product while it is in operation has increased. The number of times you have to go for servicing a particular product has reduced, and the time to resolution if failure occurs has drastically reduced. And finally, in the corporate or the CXO level people are able to now create new business models. You already know examples of how Amazons and Flipkarts and Olas and Ubers have totally changed the business model. So that's how the companies are able to leverage these technologies for focusing on new business models, as well as to modernize the workforce and also to increase the shareholder value. If I have to give example of my own company, PTC, which is a Boston-based company listed in NASDAQ, because of our future looking technologies, we are able to show and also help our esteemed customers to sustain their business, whomsoever has adopted these technologies in this very, very difficult period as well. The realization that these technologies will help them in future has happened very much. So the shareholders also are looking at such companies which are going to leverage these technologies and help industries, so that present and the future is always sustained. And one more thing is that technology may become extinct. It is a very agile and adaptable technology which gets sustained. So these technologies are always agile and adaptable and improving every day by day with new innovative ways of doing things, thus helping the entire chain of products, people, and processes. They help in integrating all these three elements into one and in a very closed loop cycle. So this will give you an overall understanding of how the technologies of Industry 4.0 and digital transformation is helping the different departments in a company. So your engineers, the engineers whom you are nurturing, will be adding value to any one or more of these departments when they go to the industry, or they themselves might be starting entrepreneurship and working towards, they will also have the elements, multiple elements of these. So if they focus on understanding that this is what they are going to achieve with these technologies by integrating the products, the people, and the process, their business, their service to the society, and overall value add to the to the world itself will increase. So in an industry, when it comes to the product development, we call it as connected digital landscape. So you start, for any product, you start with planning. There you get lot of voice of customer, you do lot of market survey, etc. That all those voice of customer is documented digitally. The advantage is that once you document it digitally, you are able to make sense out of that. You are able to make some analytics out of these different voice of customer and come out with decisions like what should be our target market, what should be our target age, what is the customer actually looking for, how does the customer differentiate us for a better service. So all that is possible because of this digitization at the voice of customer level itself. Once we get that, then we start conceptualizing and also detailing the product design in platforms like CAD, CAM, and CAE, where you do design, you do prototyping, validation, and also you define the manufacturing processes. So once we do all that digitally, then these informations from the CAD itself, the product may go into 3D printing to actually create a manufactured product. The same CAD input goes into our creation of augmented reality experience. And all this information which is generated for a product is put into the framework of PLM, product lifecycle management, where it manages starting from all the documents and the structure which is collected for the requirements of the product. Then there are a lot of system level logical structure is maintained. There are a lot of big products like aircraft and ship. They go through a system engineering process. So all those information is put in a proper structure. And then you come out with the engineering structure or the engineering bill of material, we say, the list of components which go into the products, even to the nut and bolt level. Then we do a lot of simulation and testing and validation digitally, all that information, then your manufacturing information, and then your service information. All those information with all artifacts connected to that is managed in the PLM, enterprise PLM environment. And then once the product is manufactured and released to the market for the day-to-day transactions, inventory control, etc., etc., we have the ERP system. So there is a handshake between the PLM to the ERP. So this is the digital solutions which are used in the industry to manage all the things which is concerned with the product and its processes. Now, whatever you do in AR, this AR is then used in the physical world for an actual product. We are showing Royal Enfield because they are our customer who are using AR for multiple purposes, which we will discuss later when we have the topic of AR use cases. So AR is very much used here, and that is leveraging the product design, the digital product design, and it is helping for aftermarket support. Then in the physical world itself, when it is being operated, that product is connected with sensors, that then all those details, the data, the operational data, the usage data is all monitored, and it is brought into the IoT platform. Now here you get the data from the physical world, and then you look into, say, if it is a manufacturing environment, then you look into overall equipment efficiency. If there are a lot of assets to be managing, then you look at assets management and assets monitoring. There are a lot of controls required, monitoring and processes. All that is then done in the IoT platform. Parallelly, we call the digital twin. One example of digital twin is that whatever you have in the digital world, the same replica of the physical product in the digital world, you are able to simulate it with real-time data coming from a product which is being tested on road or on a test rig. Real time it comes into the digital model. You do all kind of validations, be it CAE or motion analysis or structural, thermal, vibration, whatever it is. You replicate the same conditions while it is being operating in the physical world and make decisions by validating it digitally. And then this data which is coming in the IoT platform, all this data is again taken from either from the physical product, or it could be from robotics or robots or from factory assets, and it can be from anywhere, even from it could be from some other enterprise systems. So all this data is managed, diagnosed, proper decisions are made, and that is then in sync with the overall process. So what you see is here, there is a connected digital landscape where you see uh, CAD systems, PLM systems, ERP systems, IoT platforms, augmented reality, 3D printing, physical things, everything is connected with each other thanks to this technology and the digital way of working. So be it a bike like Royal Enfield, or be it a car, or be it an aircraft, or be it a ship, or be it a drone, or be it missiles, or be it tanks, or be it radar systems. So it is adopted well both in private as well as government industries and verticals who understand and have realized the importance of this connected digital landscape. So when we show the overall picture to any customer, this is what we picturized where they should be. They may be partially they would have adopted some of these, or they would have all these systems, but they're all in silos, they are not connected. So we show this kind of a story, so every person who is learning engineering should understand this is how the true benefit of a connected digital landscape will come once you have that close integration between the digital world and the physical world. So now let's talk about little more onto the industry 4.0. Now what is industry 4.0? Basically it is, if you take the definition, it is the application of technology to digitally transform how the industrial companies operate. From the earlier manual process, it's a complete transformation of how the industrial companies operate. And these technologies may include the industrial Internet of Things, the automation and robotics, the digital simulation, the additive manufacturing, and various types of analytics. So the main purpose of Industry 4.0 is to boost the efficiency. It is to become, the industry has to become more agile so that it can respond to this market unpredictability. The classic case is this COVID-19 pandemic which happened. The another requirement is to improve, continuously improve the quality of the product, and also to enable new business models. So that's the purpose of Industry 4.0 with all these technologies. Now, as per Acatech, there are different maturity indexes in the path of Industry 4.0. So the first thing which is required is digitalization. Every company should completely digitalize their product and process, and even their interaction with the people. So still there are companies where computerization is not 100%. That has to be done in the first stage. Then connectivity between computers, connectivity between processors, connectivity between the various things which they use in the process of product development, that should be available. So that is the first stage. Now, once they get into this completion of digitalization, then they will be able to see what is happening. They will be able to have better visibility on the process, people, and product. So that is the stage 3. Once we are into this stage, then the next stage we call it as, not we, I mean Acatech calls it as transparency. This is where you understand why things are happening the way it is happening. So this helps us to go to the next stage, which is predictive capacity, where we will be able to be prepared ourselves because we know what will happen. Since we understood why it is happening, we will be able to understand what will happen in the future. So we are able to take the necessary actions to keep the product and process uptime always. And the final one, the sixth stage, which very few companies are in this stage now, which is the adaptability. That means everything is happening autonomous. There is no manual intervention happening. Things are all self-optimizing. All the artificial intelligence and machine learning, everything is built in. The things and the processes and the systems are taking decisions on their own with all those algorithms which is built in. Actions are taken automated. Say, for example, take the example of an ATM itself. If the money has to be replenished, automatic information goes to the people who have to bring that money here. Maybe tomorrow you may even see that there is no person driving that vehicle with the money, or it could be just digital cash. There is no physical money at all in the ATM. You go and you don't even have to go to ATM. You from the home, you work now as we do online payment. Similarly, money transfer, everything which is online now. In ATM itself, the cash may also be in a digital format. You may even end up not having a physical cash if that may be an ideal situation. But things will be self-optimizing. Say, for example, you get stuck in the ATM with some problem, automatically you get connected to the support and they come on a call there itself inside the ATM, resolve your problem, resolve your complaint, and then you are a happy customer and go. There is no manual intervention happening there. Things are all self-optimizing. So that stage is what we call it as adaptability. When it comes to industry, all the machines which are working to produce the product, all the processes are all automated. Machines take their own decisions when to stop for maintenance and also maintain the uptime always. They also are concerned and self-correcting for better efficiency and productivity. Human beings at that time will spend more time on innovative planning and innovative future looking products and processes, which then they again built into the automated or autonomous manufacturing operations. So the use cases are multiple when we say adaptability. Now journeys, but to reach that stage of digital transformation, it is not a one step, it is a journey. Even PTC as a company, which has since 1985 or 1988, we are also in the journey of digital transformation. We are working along with different companies and institutions in this journey to reach the ultimate form of digital transformation. So let's understand what are the various journeys of digital transformation. Basically, we say that these journeys are more applicable into three or four areas. One is the digital engineering area. Next one is the manufacturing area. And third one is the service area. This is applicable to any product or any process. So we say that the company has to understand where they are today. So they are in the understand stage. What is the status of them in this present stage? And then how they can get into this advanced stage or outperform stage by marrying with all these different technologies, which will lead them to that autonomous stage, the last stage 6 of adaptability as per Akatech Maturity Index. So it is a little bit different for engineering, manufacturing, and service. So let's look at them one by one so that you have a better understanding. Now, all those different symbols in that at different stages, just to understand them little more in detail. The first one is called digital product definition. That means it is the product definition should be a purpose built, trustworthy product digital representation that can be used throughout the enterprise. Anybody and everybody who has to consume the definition or the information of the product, it should be available. Next one is universal data access. That means all the data which is related to a product and process should be available across the enterprise to the right person at the right time in the right amount. The third term is called performance-based analysis. That means you are totally replacing assumptions. You are getting data in real time thanks to the Internet of Things, sensors and cloud service and all these Internet of Things platform which is there. You are able to replace all the assumptions about the product performance or the product requirements because you are getting the real world data and you're interacting with the real world data. Then digital product traceability. This means if you remember the digital thread which I talked about and the connected digital landscape, the entire requirements from design to the field level, you should be able to trace all the information of that product and process. Anything goes wrong at any one stage, we should be able to trace it as to what is the origin so that we can come to the conclusion for rectification as soon as possible. Next is when you design any product, we should design in such a way that this product is easily connectable. It has got good connectivity. It will have all sensors and everything inside that so that the data, whatever is the operational data, we can collect from that so that it will help in all other previous things which we talked about. So when we try to design a particular product or process, there itself we should look at this connectivity aspect. Then design should be totally data driven. It should not be on assumptions. It should not be on thumb rules. You should be having real world data from multiple products and sources so that you can have better, uh, you know, decisions, better decisions and informed decisions. Then collaborative AR and VR design. This becomes a necessity nowadays with immersive design reviews, immersive design training, immersive service, immersive manufacturing, immersive operations, immersive sales and marketing, etc., in a very collaborative way across the product development process. Then constant analysis. Constantly, the products and processes, whatever is happening is detected, analyzed, and problems are fixed. Then even it could be fixed by the respective service guys or the customer themselves. Then predictive performance improvements. You're able to get all the data, analyze and predict its performance and also predict its maintenance. Then comes the digital twin, which I explained earlier, and outcome based design. That means you are getting the data, and because of that data, you are able to predict how this product was functioning in the field with the first design and how with the data which is coming while it is being used, that we need to change the design so that the future products and offerings are of a better quality. Then here we talked about collaborative AR VR design. Here we are talking about distributed AR VR product to view. That means the distributed stakeholders of the product and process interact virtually wherever they are and simultaneously from wherever they are so that product review happens in real time as well as in a distributed way. So these are some of the terminologies used in the digital journey. So I was saying three things: digital engineering journey, manufacturing journey, and service journey. Let's understand these one by one briefly. So we say, first understand where are you today. So to be in the first stage, it's like a Wi-Fi symbol, growing from wherever you are and growing further, and you are increasing to this extent. So we say understand stage, advanced stage, and outperform stage. So every company is trying to reach this outperform stage. There are very, very few companies who have reached to outperform stage. Even PTC's technologies or any other company's technologies have also not grown so much to have all these elements to reach into outperform stage. So everybody is in a journey now. They have achieved something to some extent, but it's in a constant journey so that we achieve the ultimate stage 6 as per the Acatech index. So in the first stage, when it comes to digital engineering, what we say is that every product should have its definition in digital form. If you look at industries, still there are a lot of companies, small and big, in India, whose product information is not completely digital. It's still on paper. Next thing is, as I mentioned, they should have a universal data access universal data access infrastructure created, framework created. Then third thing is, are the analysis being done on the product, is it performance based with the real data which is coming in? So this is the first stage. In the second stage, the company should be able to have a complete traceability of their digital product, starting from concept till the point of use. Then all their designs should be something which is going towards design for connectivity. All their design should be data driven, and they should have a collaborative AR/VR design. This is the advanced stage. Many companies are in this stage now. In the next stage, outperform stage, there is a constant analysis happening on the process, product, and even on the people. There are predictive performance improvements happening, predictive. And there is one more thing called prescriptive. So both predictive and prescriptive things happening, digital twin happening, outcome-based design, and distributed AR, VR product review. So this is the outperform stage, which most of the industries are trying to reach as far as the digital engineering is concerned. When it comes to manufacturing, in the today's stage, do you have all the machines connected? Do you have real-time issue identification? Do you have the complete visibility of your operational parameters? So that is this stage, the first stage. The next stage, advanced stage, is when you are able to do predictive analytics, when you are able to do augmented reality enabled operations, when you are able to completely leverage the power of digital thread, and when you are able to achieve agile processes and innovation. And the outperform stage is when you get into prescriptive analytics. All your operations are synchronized and automated, where you are able to do a performance benchmarking, and you also have a complete visibility of your supply chain. If any company was at this stage now, the main affected area in this COVID-19 period was supply chain. So those companies who had to some extent of complete visibility of the supply chain, they were really rescued. They sustained. Then in the service, how do you, at the understand stage, are you able to have a connected service? Are you able to monitor the usage of products? Do you have a complete service visibility? Is all your service content digital? In the advanced stage, whether your service delivery is optimized, do you also give augmented reality enabled, maybe customer self-service, or for the service advisors itself or the service agents? Do you have a process of optimized inventory and self-optimizing inventory? Do you have a process of predictive analytics? Do you have, in the outperform stage, is your service is completely customer centric and customer friendly? Do you have an automated contract and warranty optimization? Do you have digital twin in process? Do you have a business model where you sell your product not as a product but product as a service, like I was giving the example of aircraft engines? And do you have the process of prescriptive analytics? So if you have all these, then you reach the outperform stage in service. There is one more journey which is in the retail segment, where all your footwear, retail, and apparel comes into. So there, do you have an informed planning process? Do you have a collaborative development? Do you have a very good process and infrastructure to capture the voice of customer and leverage that to have your products better? Do you have a seamless vendor participation? In the advanced stage, whether the your product development is trend driven, which is not only contemporary but futuristic. Do you have the concept which you develop for any product? Say if you take an apparel, is the concept completely digital? Are your designs completely digital? Are your sampling processes completely connected? Do you have a strategic vendor partnership so that the vendors participate in your product development process much early, not at the later stage? Do you have seasonless product delivery? Amazon. You can order any kind of thing from Amazon at any season. Classic example. Do you have real-time sales insights? If you have inbuilt artificial intelligence and machine learning, etc., into this, then you will have real-time sales insights. Which product at what time of the year and how much in quantity and which region, all those kind of insights you get so that you improve yourselves and make better profits in sales. Do you have personalized products? Can you offer products which are totally personalized? Can you have transparent supply chains? Do you have a very seamlessly connected vendor exchange program? Do you have a process of continuous innovation? Continuous innovation means, say I buy one product, say from Amazon, and I give a feedback that wish this was better like this. And immediately the next product comes like that. Do you have that agility and flexibility for continuous innovation? Then you reach the outperform stage in retail. So these are the various journeys of digital transformation if you have to reach the outperform stage. So that was all which I had to present today on this topic of Industry 4.0 and digital transformation. So let me re-emphasize that. Let me go to this first slide. In this slide itself, we need to understand at what stage we are, and then our endeavor is to reach the stage 6 as per this academic maturity index. All the technologies, be it IoT, artificial intelligence, machine learning, AR, VR, and mixed reality, should benefit in such a way that we reach this adaptability stage. Like Internet of Things is something which is helping machines to be self-autonomous, machines to be intelligent. AR, VR, and mixed reality is similar to the human beings. It is making the human beings more autonomous, more innovative, and more productive. And there is a difference between AR and VR. VR is something which has been existing much before AR started. VR is virtual reality, where the entire information is virtual. You are dealing with an environment which is completely virtual. You are not at all dealing with any product or process in the physical context. You wear the respective wearables or project them, and you are trying to understand the product or process in completely virtual environment. Once you understand that, then you try to implement that understanding in your physical context. But that has created some inefficiencies. Again, you need to depend on your memory, your capability of remembering something, and your agility and your experience in understanding the virtual things and coming and doing it on the physical environment. Now, that is where this augmented reality comes into benefit. Augmented reality, what it does, it superimposes the physical experiences and information in the physical context. So then the human beings who are involved with the product or the process, they simply cannot go wrong. Let me give you one example. Suppose you are driving a car, and in your virtual instructions, you have been taught that if the car breaks down, how do I check what could be the reasons? Say your car is breaking down in a highway. And how do I check what could be the reasons of the breakdown? Whether I can fix it myself, or do I require a service person's help? Now, if you understand all that in virtual reality, you need to apply whatever you understood in the virtual reality in the actual physical situation when it happens. On the other side, you have an augmented reality experience, which could be initiated through any mobile device or tab or iPad, or even tomorrow the eyewears will become very simple. HoloLens is the best device for that, but everybody will not have HoloLens. You cannot carry HoloLens. It's also costly. So maybe a simple glass which will act as a HoloLens tomorrow. The technology is increasing. You just wear the glass and it gives you these visual instructions which you would have otherwise created digitally in front of you, in front of your eyes, saying that open the bonnet, and it also gives you one process how to open the bonnet digitally. then it tells you to look into different parts inside the bonnet, and it in the real time it gives you information on the various parameters which is of the maybe the engine, the fan belt, and the AC, and all those things, maybe even the electrical components, electronic components. It gives you information and it gives you alerts saying that the normal should have been this. It is not normal, something is abnormal. So you come to know immediately in front of you something which is wrong. Then if it is wrong, then how do you fix it? Is it fixable by you or some service agent has to come? If it is fixable by you, then it in front of your eyes, it gives you the digital step-by-step animated instructions for you to fix. If you can fix, you fix. Otherwise, you click something and your inability to fix that goes directly to the service agent, and he comes in no time to help you with. So this is one example of digital experience when it is superimposed in the physical context to help the users to be self-sufficient. It's a one example of the multiple examples which you can look at. Say, for example, if it is in manufacturing, if an operator has to change a drill bit, or if somebody is working on a PCB, he has to change some of the electronic components in that. If he wants to change it, the earlier process was that he either remember from his experience or he refers a manual catalog, or he would have referred on a presentation or video, or if it is given in virtual reality, he has to remember that. But if that instruction, changing of any particular electronic component on a PCB or on an electronic device, if it is shown to you in front of you in that physical context, step-by-step instruction, you can do that with that much efficiency and speed. So that's the difference why this augmented reality and mixed reality with devices like HoloLens, which brings everything into that real situation. Like the HOD explained, even all the sensors can also be brought into that, not only in virtual reality, in augmented reality also. So once you do that, you then, are able to do things much more efficiently, much more human friendly, and much more like in the real physical world. So that's why PTC is promoting augmented reality to a great extent, augmented reality and mixed reality. And that's how I felt that I should speak more on the topic of augmented reality in the coming sessions, which I will walk you through. So this session was for you to understand the importance of Industry 4.0 and digital transformation, which will ultimately help people to unleash the benefits across the enterprise, be it any department, by seamlessly connecting the people, product, and process. So for that, the terminologies which we need to more understand is the digital thread and the digital twin, which is made possible by technologies like IoT and mixed reality. So that was from my side on the presentation. If there are some questions, queries, I'm open for answering that.
If you have any queries, you can just post it in the Q&A session.
Any clarification, any terminology which you didn't understand, if you want me to go to any particular slide, I can go there and explain to you once more. I think as per the schedule, we have another 20-25 minutes.
Dear participants, if you have any queries, you can please ask them, or else you can put it in the Q&A session.
All these faculty who are participating are not only from Geetham University, but they're also from other institutions as well.
Yes, sir. Yes, sir. Sir, there is one question from Ashmitama. And how to start learning AR and VR from scratch? Is there any roadmap for that?
Yes. So when I talk about the academic program, which is my last session, I think I will explain to you how we help you to learn this AR and VR. But in the interim, I can send you some links, which we call it as MOOC courses, which is called micro open online courses. So they are very simple to understand and self-learning courses, which is there available online. Those links I can send it to Dr. Ajay and he can further distribute it. So you have many other such courses. Plus, I can also point you to many, real-time demonstration videos, which of course I'm walking you through in one of the sessions, which you can go through and understand how it is being used. Yes. So to your answer, there are a lot of online tools which will help you to learn AR and VR from the scratch. And after all my sessions, if Geetham University and other institutions, if they are interested in getting into an academic program with PTC, we would be happy to come and help you and give you a roadmap as well. So I see one more question. I can also read the question. Shall I read it?
Yes, sir. Sure, sure.
Yeah. So difference between AR and VR. So as I also mentioned, AR is augmented reality. VR is virtual reality. So in virtual reality, what happens? All the artifacts, say for example, if you want to understand a complete car, the entire car will be digitally modeled in CAD maybe. And then it is published in a lightweight and made available in virtually, where you have to wear a VR device. It could be from HTC or any other company. It's like a complete eyewear. Your whole eye will be covered. And this lightweight version of the digital car will be there in front of you with a lot of, interactive way of, playing with the car. Maybe you can open the bonnet, you can explore the parts and you can see all that. But everything is happening completely virtual. You are not in the physical environment. 3D games which the children play, that is the first area where we are really helping. So it's like you feel digitally you are swimming through an ocean, or you are fighting with along with the transformers, or like that. So those kind of 3D games, maybe Iron Man, all those kind of things was completely virtual. Then there came a understanding that if you are completely in virtual, how do I, particularly in the industry, how do I, bring what I understood directly into the physical context so that I get those digital instructions then and there in my physical context when I require. That is where augmented reality came. So here what you do, you have this digital experience superimposed or made available in the physical context to help you with the instructions or steps for operating a product or playing something. Pokemon Go game, if I have to take example of game, is an augmented reality example. If it was virtual reality, you would see those kind of games happening completely virtual. But in Pokemon Go, being it AR, what you see is that it's like a treasure hunt. So you walk with your mobile device, it will make you to walk through different areas. Suddenly the Pokemon will come and say, search here. In front of you, it will come. And you can see that through your mobile. So you're in a physical context. So you walk to that place and, take the clue. So like that, in the physical environment, you are getting the digital instructions. Another example, which of course I'm going to discuss in my further sessions. Say, for example, let me give you example of Royal Enfield. Royal Enfield is having a plan that when any customer comes to their dealer, if he wants to see, say, Classic 350 or Classic 500, sorry, excuse me, say Classic 500, he sees physically there in the showroom. Now that is in green color. He wants to appreciate how does that Classic 500 looks in red color. So if he is handed over an eyewear or a iPad, and through that, through its camera, he looks onto the physical classic 500, and he clicks a widget saying that color, change it to red. You will see that the physical bike which is there in front of you, which you are seeing through the camera of the iPad, the green color bike, the entire color changed to red. And suppose he says, I want a front visor to be fitted. How does it look like? So you will see, you click a widget and you see a front visor digitally superimposed exactly of the same size onto the physical component. So this is the marriage of or superimposition of digital over the physical. So you are able to appreciate the different products or accessories fitted onto the physical bike then and there, and you will be able to make a sale or appreciate the final product. So how it is made possible? It is made possible because first what it does, AR does, is it will have the exact replica of the physical model in digital. It will superimpose in the exact scale and size and form onto the physical product. And on top of that, it brings all these digital accessories, changes the color of the seat or any other additional fittings. So that is a classic example of augmented reality. If it had been virtual reality, then he will be given an eyewear, and through virtual or totally on a virtual, he will see the different bikes and he will be able to appreciate. So which one do you think is more effective? Seeing things exactly on top of a physical bike is more effective than seeing completely virtual. So that is a main difference and main benefit of AR over VR. The next question is, what is digital twin? So as I mentioned, digital twin means whatever is happening in the physical world, if you are able to exactly replicate that in the virtual world, that is called as digital twin. I will show you, I hope all these participants will be sitting through all the 6 sessions. Digital twin examples I will be showing in one of the sessions, where I will be showing you live use cases. What do you mean by digital twin? To give you immediate one example for understanding, say if I am uh, a company which makes race cars, and if I test that, I'm testing that race car on the test track, and but I have the same race car digitally modeled in my computer. As the race car is being tested, steering is turned, wheels are turning, forces are getting applied onto the vehicle, a lot of parameters are generated. If that real-time data is coming to my and is able to come to my digital model, and in my digital computer, the digital model, if I have able to see the same car which is being tested on the racetrack moving exactly the same way with all the forces coming, then it is called digital twin, right? So the exact replica of the physical product being brought in the digital environment is called digital twin. So I will show you examples, live videos, so that you will appreciate it better. And industry 4.0, digital twin is very much required, because you are able to exactly see how the machine is operating. What are the operating conditions, how the things are moving, is there any problem, is there any downtime, is there any maintenance to be done. So this you are seeing in a digital screen real time. Maybe it could be a representation of the machine, could be not a complete 3D model of the machine, it could be a nice sketch of the machine, but the different parts of the machines is represented, but the digital parameters of the machine is in real time shown on your computer screen. So that is also an example of digital twin. Okay. Another very good question is, how is India doing in this sector? Yes, so India has already started adopting. The companies which I have shown you, like Royal Enfield and Tata Motors and DRDL, etc., in this slide, in the connected digital landscape slide, this here, all these companies have started adopting these technologies. So of course we are little behind, but this COVID-19 has made people realize there are a lot of companies which have already started adopting, have come back to us saying that since we have adopted these technologies, our business was as usual. Those who did not, they really uh, stand at the back. I mean, they don't stand to be gained with this, in this situation. So how far we are behind, I would not be able to say, but we are definitely catching up. And mind you, most of the global companies, they have their presence in India. Most of their engineering center of excellences are in India, and to be specific, in Bangalore also. So we are much ahead. Our people are quite, understanding. Only thing, it has to be understood. Say, for example, if I sell a product with a sensor, the first thought process is that will my customer pay for that extra cost? We are very, very cost conscious. Will they pay for that? Is the first thinking. But now with all these technologies and Amazons and Flipkarts and the advantage of this service and volume purchase, you're able to reduce the cost and you're able to sell more the value so that the customer is able to appreciate, yes, this is value for money. So there are certain glitches which has to be changed in the thought process of the Indian customers, and that is being done. Then this will be at a very faster pace. But to give an answer, yes, not only companies, but premium institutions like IITs have all are adopting these technologies and showcasing to the industry how it is going to be beneficial. It is actually going to reduce the cost rather than increasing the cost. So it is just a matter of organizational adaptation and organizational attitude change. Any other question? Mixed. What is mixed reality? So augmented reality is actually a superimposition of digital experience in a physical context. So for example, if I have to say play a ball game, so on to that, say if it is a table tennis, on to the table tennis table, if I have a digital table tennis ball, right, showing me how to play, that is called augmented reality. Now mixed reality is if I am having a racket and if I am able to interact with that ball which is digital and play. So there is a digital and physical, collision happening or interaction happening in real time, then it is called mixed reality. So when I play, there are a lot of games, right, in Xbox and all those things. You wear something and you feel that you're actually playing. So what happens? The ball, which is digital, actually goes and hits the table, goes to the other side, and somebody else is hitting and comes to this side. You get that feel. So it's a proper the feel, the interaction of the digital and physical with that feel, then it becomes a mixed reality. So when digital things actually interact with the digital things to give you a physical feeling, then it becomes a mixed reality, and that is only possible with devices like HoloLens, etc., which can give you the experience of augmented reality as well as mixed reality. In industry, what we do is we see a complete equipment, physically in front of us. Then we use a gadget wherein we can interact with each component. We can pick that component, take it out, turn it up and down, bring it close and interact with that and place it somewhere else on the component, on the product. So that is a real interaction happening. Of course, it is a digital interaction, but it is a real interaction. So I'm taking the component out and putting it in some other place. Those kind of examples are called mixed reality. Somebody wants to develop a digital twin. Do I need to know CAD CAM? Okay, if you are doing a product design, it's 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 what you want to apply the digital twin on. Suppose you are completely on IT and you want to simulate something, a system based on the data which you're getting from the physical system, then you don't need to know CAD CAM. You can have a replication of that in whatever form in the digital system, say for example in the IoT platform like ours, and then you can have all those parameters change in real time to understand how the IT system operates. But if you are a product designer, then you have to understand what is CAD. You will have a digital model which is created in CAD, so that CAD model reacts to the inputs which you are getting from the physical sensors. So it is the application which is deciding whether you need to know CAD CAM. So if it is purely an IT system which you're trying to replicate, you may not require CAD CAM. Programming language is part of every system. If you look at PTC's augmented reality and IoT platforms, the programming knowledge required is very minimal. Most of the things are all drag and drop, but still if you know Java programming, you can actually customize whatever you're creating to a much more greater extent. So if you know programming language, it is definitely an advantage. Basically, our systems work on Java, and our CAD systems work on C, C++, right? Whatever you are trying to do in Python, all those things will help you in understanding the overall algorithms, but you don't require that specifically if you are operating in our system. In our system, mostly you require Java, which is very easy to learn. And we also provide a lot of sites where you can actually copy paste a complete Java snippet for a particular thing to be customized or, made into the digital world. Is there any privacy or security issues present in AR devices? Any cyber systems will have its own privacy and security issues, but all the systems, what we do, there are a lot of different levels of privacy and security issues built in. In fact, if you ask me, I always ask, another question to all of you. You have been sending emails from so many years. You have been operating with online banking for so many years, where our own hard-earned money you are dealing with. Have you thought whether this is having highly secured? Is it highly secured? If you have thought about it, then you are in the right track. And yes, all these banking systems and emails, many of them have got a lot of multiple layers of security inbuilt. Still, people are smart enough and they can hack into, and then you can counter it. That process will continue. But 128-bit encryption, 256-bit encryption, multiple types of layers of security, multiple types of authentication processes. When you transfer data from one point to another point, nobody is able to retrieve it, understand that. All those kind of security and everything is inbuilt in AR as well as IoT. When you send data from your mobile to the cloud or from cloud to your mobile, everything is encrypted and it is highly secure. See, particularly in the education industry, it has been used quite well. You can teach many things. I don't know, Mr. Sanjay is from which department. If you are from mechanical department, I can give you an example saying that suppose you want to teach a differential. How does a differential work? You can have an actual AR experience created to make them understand how does a differential work. If you are an electronics engineer, how does the different components in a PC, what are the users, how do you fit them? All those can be created as AR content and can be taught to the students in real time. You can take them to the physical prototypes available in your labs, say cut models, and you can superimpose that physical prototypes with the digital instructions and show them the operation. Say for example, if it is a mechanical engineer, you can show the operation of a engine. You can show the entire operation. If it's a electric vehicle, you can show the entire operation of a electric vehicle with the digitally superimposed process in your lab. So we do all that in our academic program. I will be talking about that in my last session. We say that we do COE labs, Center of Excellence labs, where we teach how to work on AR software and then make them to do projects on AR, so that you apply your learning process with the help of the digital instructions or experiences created in AR, VR, and MR. If I go, when I am visiting a lot of engineering colleges and particularly interacting with mechanical engineering department, if I ask a final year student to explain to me how does a differential work, what is the basic principle, he is not able to explain to me, even though he has scored high mark. Why? Because he has just learned it and vomited in the exam. He has not understand the basic concepts. Is it the problem of the faculty which is teaching or the system, or is it the method of teaching is problem? I don't know. But if you show that working of the differential in actual digital experience superimposed on a cut section of a differential, he will understand it better. In fact, there has been a study done by Boeing where 3 groups were formed, and each group was given a task of doing 50 different things over an aircraft wing 50 different processes twice. The first group was given normal manual instructions. The second group was given a computer digital same instructions but given on a digital format in the computer. The third group was given an AR with an iPad. They were given an AR instruction. And the study was this group has to do that 50 process twice. So the first time they will do, now they understood how to do, again second time they will do. And they found very interesting results. They found that the group which had AR instructions, the first time the speed with which they did was much faster than the other two groups, and the error which they committed was also much less. In the second time, the error was 0, whereas other groups still had errors. So very interesting study done by Boeing, and that's how it is helping for the industry as well as to the education. So unless in the education industry, if the students understand the importance of AR, VR and MR and apply that in their own small projects or in collaboration with industry, and why they are supposed to be learning in education, I am covering in the academic program. There's a lot of skill gap in the industry. We do not have engineers who are well versed with these technologies of AR, VR and MR. There are different disciplines which has come now, AI, data and all those things, but it is still that practical skills is still missing. So industry is going ahead, but we want the skills coming from such institutions, and that's where we are trying to promote these technologies. So the future engineers, as I mentioned in my first slide, we need institutions that produce engineers of tomorrow with multidisciplinary skills. A mechanical engineer should not limit himself to understand only the mechanical systems of a product. He should also understand the integration between electronics and electricals, etc. So that's where the academic institutions are very, very important, where these technologies need to know. So I think I have answered most of the questions which I saw here. If there are more questions, you have few minutes. Otherwise, we will take a break and rejoin at 12 o'clock.
Any further queries? I think no queries, sir. Thank you, sir, for enlightening us on this topic, Industry 4.0 and industry and digital transformation. It was a wonderful session. So we will meet again at the next session will start at 12 o'clock.
Okay.
Thank
fine.
you, sir.
Thank you.
Sir.
Thank you.
I request all the participants to please fill the form, feedback form, which is posted in a chat window. And I request all the participants to rejoin at sharp 12 o'clock using the same link provided.